Okay, let's get into it. We're doing a deep dive today on something that, well, it might seem a little too simple at first. The traffic light.
Right. 3 colors. We learned it as kids.
Exactly. You see them every single day, and you just think you know the rules.
Mhm.
But the sources we've got, and we're talking a pile of safety reports, accident analyses, they all show that signal-controlled intersections are consistently one of the most frequent crash points.
And often one of the most deadly. It's true. We're sort of conditioned to see them as just simple instructions. Green is go, red is stop.
But it's not that simple.
No. The reality is that those few seconds you spend interacting with a signal, especially in that moment of transition, they demand a level of defensive strategy that most drivers, frankly, just haven't mastered.
So that's our mission today. We want to cut through that complacency. We're going to move beyond just knowing the colors and give you actionable defensive strategies.
The overlooked habits that prevent collisions.
Yes. We're going to solve that ultimate driving riddle, the yellow light dilemma, and even get into who the technical puppet masters are behind this whole thing.
And here's the first thing that just jumps out from the data. The amber, or the yellow light, is statistically the most dangerous phase.
The most dangerous.
By far. It's a psychological trigger. Drivers don't see prepare to stop. They see it as the last chance to accelerate and beat the change. And that leads to much, much higher collision speeds.
Well, that completely flips conventional wisdom on its head. So if speeding up is the big mistake, how do we master that moment? The amber light flashes. How does a safe driver decide whether to stop or go?
This is where the source material gives us a pretty clear decision matrix. It's all about prioritizing safety over speed.
Okay.
First, you have to instantly assess your distance and your speed. If you are extremely close to the intersection, the sources say, within 100 feet or a few car lengths, proceeding is usually the safer choice.
Because slamming on the brakes at that point is actually the error.
It's the error, exactly. An abrupt stop in that zone creates a very high probability of a rear-end collision, which can be just devastating. But if you're farther back and you have plenty of time and distance to come to a smooth, safe stop, then stopping is mandatory. You also have to factor in the conditions.
Rain, ice.
Higher speeds, slippery roads. You need way more distance to stop safely, so braking hard is just incredibly dangerous.
All of that is a split-second judgment call, which brings up the traffic behind you. That rear-view mirror check on yellow, that's the key, isn't it?
It's completely non-negotiable. You always have to glance at your rearview mirror.
Always.
If the driver behind you is tailgating or just coming up way too fast, stopping suddenly is basically just starting a rear-end crash yourself. The goal is to avoid any collision.
And this whole decision matrix has to be processed in, what, a fraction of a second? This is where we hit the limits of the human brain. Reaction time.
That's the one. The typical driver's reaction time. And that's from the moment your brain even sees the light change to when you physically start to react. Move your foot to the brake. It's about 1 to 1.5 seconds.
That doesn't sound like a lot, but let's put that 1.5 seconds into context. Say you're traveling at 45 miles an hour.
Yeah.
What does that 1.5 seconds of just doing nothing actually mean?
Well, at 45 miles an hour, you're covering about 66 feet every single second.
66 feet.
So in that 1.5 seconds it takes your brain just to process the light, you've already traveled nearly 100 feet. That's the length of a busy intersection. Before your brakes even engage.
100 feet of blind travel. That really puts into perspective why things like fatigue or distractions are so lethal.
They just lengthen that gap. Fatigue, age, a tiny distraction like glancing at your phone, that can easily push your reaction time past 2 seconds. So you travel 100 feet, then add another second. That's another 60 feet before you're even trying to slow down.
Wow.
And impairment from, alcohol or drugs, that just compounds the delay and destroys your judgment.
Okay, let's pivot from the yellow light to the much more clear-cut danger of running a red. The sources point to this fundamental assumption error that people make.
They do. It's this idea that traffic is a perfectly timed machine. The biggest mistake you can make is assuming that just because the light is green for you, it's automatically safe to go.
A green light isn't a guarantee.
It is not a guarantee. A green light is merely permission to check that it's safe to go. That's all it is.
And when that assumption fails, what are the consequences of blowing through a red light?
They're severe, really severe, because of the angle of the crash. Running a red light almost always results in a T-bone or a broadside collision.
Right into the door.
Right, which means the crash energy is going into the side of the car where you have the least protection. These are often high speed and they lead to far more serious injuries. And of course, the incredible danger to pedestrians who are relying completely on that red light for their safety.
The studies we looked at broke down the psychology of why people run reds, and the categories are just fascinating. The obvious one is the beat light runner, who just guns it.
Sure, but then look at the more subtle ones. There's the too early driver.
I've seen this.
They anticipate the change, and they jump forward just a split second before it turns green, and they risk hitting someone who is trying to beat the red from the other direction. Then you have the confused driver.
Who's not paying attention.
A total lapse in concentration. They might genuinely stop on green or go on red just because their head wasn't in the game.
And then you have the chancers, the people who see the red light as more of a suggestion.
Precisely. The sources call them out. Drivers who try to sneak a corner, like a quick right turn on red when they shouldn't, or the cut-through where a driver sees a tiny gap in traffic and just darts across.
It's all just being hasty.
It is. Prioritizing speed over basic safety.
This analysis leads to maybe the most controversial, but also most critical piece of advice in the whole report, the stop dilemma. You're coming up to a red, you need to brake hard, but you see a truck flying up behind you.
And this is an extreme scenario. We have to be very clear about that. This is not permission to just run red lights.
Right.
This is for when you are faced with two immediate terrible threats and you have to pick the lesser of two evils. So you're about to stop hard for a red and you see a high-speed vehicle in your rearview mirror that is not slowing down.
So if stopping means you are absolutely 100% going to get hit from behind at a catastrophic speed.
In that extremely rare circumstance, where the impact from behind is a certainty and it's going to be devastating. The sources suggest it may sometimes be safer to proceed through the red light.
Wow.
But only if you can clear the intersection safely and you're not putting cross-traffic at immediate risk. It's all about situational awareness, protecting yourself from the immediate high-certainty threat.
That's a staggering point. But it really underscores that primary lesson. Never rely only on the color of the light.
Absolutely. You are the safety system, not the light hanging over the road.
Let's shift now. We've talked about the human decision. What about the threats that are just lurking in the intersection itself, the hidden hazards?
We have to start with the classic. Oncoming traffic, crossing your path, usually left turns. The danger there comes from drivers who are either oblivious to you or they just take a chance.
They try to squeeze through a gap that isn't there.
It's not there. And the sources specifically call out U-turns as a high-risk factor.
Why is that?
A U-turn is a slow maneuver. It forces the vehicle to slow way down, and it takes up a huge, vulnerable part of the intersection. It dramatically increases how long you're exposed to traffic, and we always have to be aware of obscured views, blind spots from buses, big trucks, signs.
Anything that can hide a reckless driver.
Exactly. But it's not just the cross traffic, it's the cars going in the same direction as you.
How does that happen? Everyone has a green light.
It happens all the time when drivers don't maintain their lane through the intersection. The sources call it street both, where two drivers going straight drift into each other's lanes.
Or one turns across the other.
Right. And a really common one is turning both. Imagine two cars side by side, both turning left onto a road with two lanes. If the driver in the inside lane turns too wide and crosses into the path of the driver on the outside, that's it. It's a collision born from just not staying in your lane.
We have to talk about the confusion from turning arrows. The feeder arrow. This is such a layered hazard.
It is a massive source of misunderstanding. The first problem is that a dedicated turning arrow can sometimes trick oncoming drivers into thinking that since you're turning, they can also go straight, even if their light is red.
I can see how that would happen. What's the second layer?
It's when that green arrow turns off and the signal becomes a solid green circle. The turning driver often mistakenly thinks they still have exclusive access.
But they don't.
No. The solid green means oncoming traffic now has the right of way to go straight, and you have to yield. That transition from exclusive to shared right of way is where accidents just spike.
And quickly, let's just mention the other hazards. Trucks and weather.
Simply put, trucks are dangerous because of their mass and momentum. Stopping distance is huge, collision severity is extreme, give them space. And slippery conditions, they require more than just slowing down. They require a commitment to added space for everyone's errors.
Okay, let's shift gears and look under the hood of the system itself. What happens when it all breaks down? When the lights just fail or they're flashing?
This is critical survival knowledge. When a traffic light is completely out, it's dark, it's not working, the universal rule is you must treat that intersection as a four-way stop.
So come to a complete stop, no matter what. And then what's the rule for who goes?
Standard four-way stop rules. You yield to the first car that got there. If two cars arrive at the same time, you yield to the vehicle on your right. Never, ever assume someone else is going to yield for you when the power is out.
Okay, that seems vital for keeping order. What about the flashing signals? Flashing red.
Flashing red is simple. It is a stop sign. You treat it exactly like a stop sign. Come to a complete stop, look, yield to everyone, and then proceed when it's totally clear.
You see that at railroad crossings too.
Yes, same rule applies.
And flashing yellow. That's the one that means caution, but not a mandatory stop.
Correct. Flashing yellow means proceed with caution. You don't have to stop, but you must slow down, be prepared to stop instantly, and yield if you have to. It's basically a sign that you're entering an area that requires, extra vigilance, a construction zone, or late at night sometimes.
So let's get technical for a minute. Who is actually pulling the strings behind all this coordination?
It's mostly local transportation agencies, your city or county road department. But the key players are the traffic engineers. They're the ones analyzing all the traffic data and trying to optimize the timings for both efficiency and, of course, safety.
And how do they decide when to change the light? It's not just a simple timer anymore, is it?
Not usually. There are two main ways. You have the old predefined timing plans, which are just fixed intervals, but in most busy areas, they rely on detection systems for real-time input.
I always wonder about those sensors. What is actually sensing my car when I pull up to a red light?
You're most likely sitting on top of an inductive loop sensor. You can sometimes see the outlines cut into the pavement.
The black tar lines.
Yes. Think of it as a big metal detector under the road. Your car is a huge piece of metal, so when you drive over it, you disrupt a magnetic field, and that signals the controller that a car is waiting.
Just a simple magnetic field. That makes perfect sense.
Yeah.
What else is out there?
The newer systems are often video detection cameras or radar microwave sensors. They're mounted up on the poles. The video systems use imaging to see and track cars and pedestrians. The radar uses microwave beams to detect movement.
And those cameras, they're not just for traffic flow, are they?
No, they have multiple uses: traffic analysis, vehicle detection, and, yes, the controversial red light cameras, which are used purely for enforcement. They snap your license plate if you run the light.
We've covered a huge amount of ground here, from that critical 1.5-second reaction time to the tech that's watching us. Let's bring it all back home. What is the one fundamental takeaway from this deep dive?
It has to be a total commitment to situational awareness. Never, ever let the color of the light override your own responsibility to check that an intersection is safe. Always assume other drivers will be oblivious that they might not see you or that they'll run the red.
And on that yellow light, use that safety checklist.
Absolutely. Distance, speed, and the traffic behind you.
Yeah.
Use that matrix to make the safest possible decision, even if it feels counterintuitive.
The safety of the whole system really rests on the drivers. But let's end with a final thought, because this simple system we rely on every day, it had a really dramatic, explosive start.
It really did. The very first traffic signal is credited to J.P. Knight, a railway engineer. It was installed in London near Parliament way back in 1868.
1868.
And it used semaphore arms during the day, but at night it used red and green gas lights.
Gas lights in the middle of an intersection. That sounds like a terrible idea.
It proved to be exactly that. In 1869, less than a year after it was installed, the gas light exploded and seriously injured the police officer who was operating it.
Oh, wow.
It was immediately removed, deemed too dangerous. It took decades for the modern electrical system to come about, and the most critical part, the yellow light, that wasn't added until 1920 by a police officer in Detroit named William Potts.
The one color that forces us to pause and think. So next time you're sitting at a red light, just remember that the whole system we rely on was born from an explosion and took over 50 years to get right.
Stay alert, stay safe, and thanks for taking the deep dive with us.
Please like, subscribe, and get notified.